In this video, I'm going to talk through the process of finding side measures if you're given an angle of a right triangle and also another side. So one of the sides is going to be unknown, and we're going to use the information of an angle and another side to help us find that. Alright, so in order to do this, you have to first put your calculator in degree mode. Alright, so if you're going to take your calculator, you turn it on, you hit the mode button, you scroll down to where it says radian, and you scroll over to degree and hit enter. And now degree should be highlighted, and if that's the case, you can hit second mode to quit out of that and go back to the home screen. Again, hit mode, go down to radian, scroll over to degree and hit enter, and then quit out of that by second mode. Good. Now your calculator is in degree mode. That will be a clue if you're not getting the right answer, or the answers I'm getting, you should probably check that to make sure it is in degree mode. And we need to do that because we have degrees. The angle in question in my first example is 64 degrees. And so that tells me to put it in degree mode. Now, we are going to use a calculator to find the length of a missing side. And I do want you to round to the 10th decimal place. And in order to do that, we have to set up the trigonomic functions that we practiced in an earlier objective. And then based off of this function, we can use proportions to solve for the missing side length, or just solve algebraically as well. And I'll show you how to do that in actually two examples. I'm going to do two different examples because the solving process is a little bit different in both of them. Alright, so to begin, before I start, I know that it's right triangle trig because of that right angle right here. That square signifies that that's a right angle, so I know this is a right triangle. Anytime I'm using right triangle trig, I'm going to use the acronym SOHCAHTOA. So I'm going to write that down to help me reference it very quickly. So I suggest you write that down as well. And then I need to label my triangle in reference to the given angle. All right? Remember, there's three pieces of a right triangle: the opposite, the hypotenuse, and the adjacent. And in this case, I need to label that according to the given angle of 64 degrees. So to do that, I can always start with the hypotenuse. The hypotenuse is the side that sits across from the right angles, and it's the longest side. So this is the hypotenuse across the right angle. And then the opposite and the adjacent. If you remember, the opposite is the one that jumps over the angle, or you jump over from the angle to the opposite side of the triangle. In this case, it's down here. And the opposite's also the one that's not touching the angle by any means. And then finally, the adjacent is the side that's right next door to the angle, that is actually makes up part of the angle but is not the hypotenuse. So I have labeled my triangle correctly, and if you notice then, the unknown side that we're trying to solve for, x, happens to be our opposite side in this case. That's going to change just depending on the triangle that's given to you, okay? Sometimes it'll be adjacent, sometimes it'll be the hypotenuse. And then the known side that we have is the adjacent side. And so it is very important to do this step because now this is going to tell me what trig function I need to use to set up my proportion or set up my equation. I have this triangle gives me two sides in reference to the angle. It gives me the opposite and it gives me the adjacent. So this is where I'm going to reference my acronym SOHCAHTOA and look for which trig function, sine, cosine, or tangent, that contains the opposite and the adjacent. In this case, tangent does. Tangent has the opposite over the adjacent. It's the only one that contains both. And so I'm going to write tangent, and to set it up correctly, I'm going to put tangent of the given angle, which is 64. And I'm going to put equals. Opposite, in this case, is our unknown, x, over the adjacent, which is given to us as 11. So at this point, I have set up my equation correctly. I have an unknown in the numerator, and it's being divided by 11. And I got that based off of labeling my triangle correctly, so it's a skill built upon a skill. Now, from here, I can go ahead and solve for my unknown variable. Like I said, it's being divided by 11 on the right-hand side, so I can multiply each side by 11. And those cancel out, so I'm left with x equals 11 times the tangent of 64. And you can put that in exactly like you see it on your calculator around to the 10th decimal place. So I'm going to do 11 times, on my calculator, 11 times tangent of 64. Please go along with me on that so you can get the same number as me to check that you know how to work the calculator correctly. And I get 22.55, so I'm going to round that to 22.6. So the unknown side length in question for this triangle is 22.6. And I am done. Let's move on to example 2. Before I start this, I'm going to have you change the given pieces of information. Please cross out the 12 and put the variable x on the hypotenuse, and please cross out the x and put a 4. Alright, because I want to show you a different way this can work out. So please make sure you do that. And now I'm going to solve for x the same way I did in example 1. I first need to label my triangle in reference to the given angle, which in this case is m. M is 15 degrees. So I need to label hypotenuse, opposite, and adjacent. Hypotenuse is always across the right angle, so that's the hypotenuse. And if you notice, the hypotenuse is my unknown variable x. That's what I'll be solving for. Then opposite of 15 is my given piece of information, 4. And then adjacent doesn't come into play here. So from there, after I label the triangle, I'm going to look and see that I have an opposite piece that's given to me, and I have a hypotenuse piece that is my unknown. So I need to look at the trig, or the acronym SOHCAHTOA, and look for opposite over hypotenuse, or opposite and a hypotenuse. And in this case, sine contains both opposite and hypotenuse. If you notice, cosine is adjacent, hypotenuse, tangent is opposite and adjacent. So sine is the only one that has opposite over hypotenuse. So I'm going to write then sine of the angle in question, 15, equals, and again it's opposite over hypotenuse, referencing this. So the opposite is 4 over x. And I wanted to show you this example because if you notice, x is in the denominator, alright? And there's two ways to go about this. You can remember a little shortcut and, wait a minute. If you remember a shortcut, whenever the variable is in the denominator in a proportion, you can just switch the locations and put x equals 4 over sine of 15, and you automatically have solved for x. If you don't want to do it that way, then the second way would be just to multiply each side by x. So now I get x times sine of 15 equals 4, and then to solve for x I would divide by sine of 15 on both sides, divide by sine of 15, those cancel out, so I get x equals 4 over the sine of 15. And if you notice, it's the same thing. So if you can remember that whenever the variable's in the denominator, you can just switch the locations of the two, or if you actually want to solve it by multiplying x out of the denominator then dividing by the other piece, fair enough. But eventually you should get x equals 4 over sine of 15. And if I put that in my calculator, 4 divided by the sine of 15, I should get 15.45, and that 5 rounds the 4 up. So I get x equals 15.5. And I am done. So, at this point, the video is complete. Please try these 4 problems on your own. Again, labeling each triangle in reference to the given angle. That's the first step, and it's very important. And then figuring out which trig function to use based off of the pieces that are given to you. Thank you for watching.